Okay, math marvels, tons of elementary school, middle schoolers hate simplifying fractions because there are so many steps, and what if you don't know the greatest common factor? So I'm going to show you a way you can use prime factorization, just another tool in your toolkit to simplify a fraction. What you're going to do is you're going to think of each number in your numerator and your denominator and think of the factor pairs and find which factors are prime factors. Let me show you. We'll start with 24. One way I can break up 24 into factor pairs is I can do 8 times 3. 3 is a prime number. The only way I can get 3 is 3 times 1, so I have it in a different color. But I can keep on breaking down 8. I can break down 8 into 4 times 2. 2 is another prime factor, so I just leave it alone, but let's break down 4 some more, and I can break that into 2 times 2. So here are all the prime factors of 24, 2 times 2 times 2 times 3. And watch, I'm going to do the same thing with 36, break it up into factor pairs. So the first pair is 9 times 4, and it doesn't matter what pair you use. You could have used 2 times 18, you could have used 3 times 12. Just pick a factor pair, as long as it's not prime, keep breaking it down. And I can break these down into 3 times 3, and I can break 4 into 2 times 2. Now, watch what I'm going to do. I'm going to take the prime factors. So there's 24, and I'm going to do the same thing with 36. And now that I can see its pieces, all I'm going to do is look for the pieces that are the same. Find a pair that are the same. And why do you want a pair that's the same? Well, because when you divide a numerator and denominator, it's the same number, like 2 divided by 2, you just get 1. So that goes away, it gets into an easier number. So here's another pair that's the same. And I can take a 3 and a 3. That's the same. So what I'm left with is 2 over 3, and it is simplified. So prime factorization is another way to make sure you simplify a fraction to its simplest form. Here's another way you can do it. You could actually just think, do they have any common factors? And so I like to think of the easiest ones, common factors, 2s, 3s, and 5s and 10s. These are the ones that are really easy to see. If they're both even, you can divide them by 2. You can use a halving strategy. If the digits add up to 3, 2, 3, 6, or 9, then you can divide both of those numbers by 3. If they end in 5 or 0, you can divide them by 5. They have a 5 in common. And if they end in 0, you can divide both by 10. So these are like the quick rules that I use. The easiest one to spot is, are they both even? And looking at these, so I can tell they're both even. So a lot of kids just half it a lot. And they just use the, oh, I could divide both of these by 2, so it just goes 12 over 18. And when they look again, up, they're both still even, so I'm going to do the same thing, divide by 2. And my issue with that is you're really dividing by 2 over 2, so you're just halving it again, and you're getting 6/9. Now they're not both even, but do they have any other common factors? Well, look at 3. If they add up to 3, 6, or 9, and they both have a 3, a 6, and a 9, so I'm going to divide both of them by 3s. And I get 2/3. So I still get the same answer, 2/3, 2/3 in both methods. And I see a lot of people using this strategy. So for example, even if I had a bigger number, like 40 over 84, people just go, oh, they're both even, I'm going to half them. 20 over 48. They're both even, I'm going to half them. 10 over 24. They're both even, I'm going to half them. 5 over 12. And then at this point, it is already in simplest term. The only factors I have for 5 are 1 and 5. And 5 is definitely not a factor of 12, so it is already in simplest form. So a lot of people do love the halving strategy. But remember, you could also look to see, is 3 also a factor, 5 or 10? Those are just other ways. Good luck this year with simplifying fractions. It is super helpful, and it ensures that everyone has an equivalent expression in lowest terms.